let's state what the fundamental theorem of calculus is. And this is kind of, I don't know, once I write it, I think it will be obvious, but maybe not. The integral from a to b of f prime so the antiderivative of the derivative go ahead, isn't that that's just f of x with the limits plugged in, so wouldn't that just be f of b minus f of a? And yes, so that's the fundamental theorem of calculus. It seems like this grand idea, but you think about it, you're like, wait a minute, the antiderivative of the derivative, that's just back to f. It's like the square root of x squared. Well, that would be x. It's the same kind of thing. If you antiderivative a derivative, you're back to where you started. Now, we do introduce a little bit different variable, because sometimes we don't call this f prime, we call it f. And so we need a different variable for like going backwards. Like, right, if we start at f and we take a derivative, it goes f prime, f double prime, f triple prime, f quadruple prime, and so on and so on. But if we start at f and go backwards, like there's like a, what do we call that? And somebody long ago decided that we'd call it uppercase f. So those two things say the same thing. It's just the first statement I feel like is far more obvious because it's the antiderivative of the derivative. Here we have to know that the antiderivative of little f is big F. It's like there's capital F, we take its derivative, we get little f. We take its derivative, we get f prime, and then double prime, and then so on down the line. Now, here's the big deal. We've talked a little bit about making the connections of what this means. And probably the first thing we did to find that on the last test was area under the curve. Now that really only worked if it was a nice shape. So those were definitely rigged problems. They were either semicircles, rectangles, or trapezoids. That was about it. Maybe triangles. Area under the curve. So we've done that. We did a little bit of yesterday and the day before. We did antiderivative, where we took the antiderivative, sometimes with u substitution, sometimes not, to figure out what that was. And then what we'll add today is using the calculator, which is great. It's the easiest of all of them. I mean, we hope you understand what you're doing with the calculator, but the calculator does the work for you. And so part of the trick difficulty of this unit is when you see that, you have to be thinking all of these things. Well, that represents the area, but it also represents the antiderivative. And if I don't know the area and the antiderivative is crazy, then maybe I have to use the calculator to find it. And so it's a little bit tricky. If I give you that, like, well, how do I figure out what that is? Which method do I use? And sometimes it's obvious and may tell you which method to use. Obviously, if it's on the no calculator test, then you won't have a calculator. If it's on the with calculator, then maybe you could use the calculator. All right. Given dy dx equals 3x squared plus 4x minus 5, with the initial condition y of 2 equals negative 1, find y of 3. Method 1 we've done before. Integrate, use the initial condition to find c, and then plug in 3 to figure out your answer. So let's do that one, hopefully kind of quickly. So let's integrate all of those pieces. In fact, I said quickly and then I decided I'll call on people, which isn't exactly quickly, but that's okay. There's 3 pieces there, so I need 3 volunteers. So Tierney, Emily, Mark, in that order. Tierney, what's the antiderivative of 3x squared? Good. Emily, how about the antiderivative of 4x?
4x squared over 2.
Good. I'm going to go ahead and simplify that to 2x squared, but what you said was right. And Mark, the derivative of negative, or the antiderivative of negative 5?
Negative 5x.
Good. Negative 5x. And then, I should have pulled one more stick, because what am I missing?
C.
Plus c. But we know that y of 2 equals negative 1. So if I plug negative 2 in for y, negative 1 in for y, 2 in for x, negative 1 in for y, 2 in for x, yeah. I can figure out what c is. 18 minus 10 is 8. No, 16 minus, 18 minus 10 is 8, but 16 minus 10 is what I need. So c is negative 7. That's really similar to that one differential equation problem you had on the last test, right? Integrate, use a condition to figure out what c is. This takes it one more step. It says find y of 3. So that means I'll plug in 3. And I know what c is, so instead of plus c at the end, I'll have minus 7 at the end. And that would be a safe stop, right? You plugged it in, so you're good. But to make sure we can compare it to method 2, let's go ahead and go the long way around here. 2 times 9 is 18, minus 15, minus 7. So that's a lot of things to add up. 45 minus 15 is 30, minus 7 is 23. Okay, that's old news. Like, we should already know how to do that. So kind of set that aside. That was method 1. Method 2 says that if we integrate a derivative, we get back to the original. Well, we know what the derivative is. So let's integrate. The derivative was 3x squared plus 4x minus 5. And now we need limits on our integration. Now we were told y of 2 equals negative 1, and we're looking for y of 3. Are our limits x values or y values? They're x values. So which x values do you think we should use for this problem? 2 and 3. And we should probably go 2 to 3, although you could do it backwards, and then you'd have negative signs to deal with. So let's go small to large, 2 to 3. And so thinking back to the antiderivative of the derivative gets us back to just the function of the top minus the function at the bottom. Well, we know, which one of these things do we know? We know f of 2, we're looking for f of 3. So I can add f of 2 to the other side. To find f of 3. f of 2 we know, f of 3 we're looking for. Then this integration, we could do that. So f of 2 plus, let's see, we already integrated this once, so this shouldn't be too bad. X cubed plus 2x squared minus 5x. I don't have to worry about the plus c because it's a definite integration. I'm going from 2 to 3. Let's see, let's start plugging things in. F of 2 is -1. And then top minus bottom, once I've integrated, and we've integrated, so now we can do the top one minus the bottom one. So plug in 3, and then plug in 2. And is that a safe stop? Yeah, that's calculator ready. It's a mess, but it's calculator ready. Now, just to confirm, if I type it all into the calculator, I get 23, which is what we got in the first method. Now, I don't know which one of those methods is easier, because you had to integrate either way. You had to plug in 2 and 3 either way, different places. So they look a little different, but you end up at the same spot. The real reason we like the second method is this next example. Sometimes there is no antiderivative. So we have to use method 2 with the calculator. All right, so f prime is sine of x squared. F of 2 is -5. We want to find f of 1. Okay, well, if I'm looking for f of 1, and I know f prime, I should probably integrate f prime, because that would give me f of x. Pretty key point here is what x values should I use? 2 and 1, because those are the ones involved in the problem. So, and it doesn't matter which order you go in, but most people are going to go smallest to biggest, so I'm going to go 1 to 2, and then that would be f of 2 minus f of 1. So from 1 to 2, we know what f prime is, sine of x squared. F of 2 is -5. F of 1 is what we're looking for. So I'm going to do a little bit of algebra first to get f of 1 by itself. I'm going to add it to the right side, or add it to both sides to move it to the left side, and then subtract that integral over that whole thing. So that was, I mean, there's calculus stuff there, but that step was just algebra. All right, I moved f of 1 over, and I moved that integral over. So math, grab the calculator, it's dying. So math, and really if you scroll up you get there a lot quicker. Yes, FNINT, function integration. You press that, and if you have the right calculator, it's like, it makes it look like it's supposed to look. It's like, this is amazing. The old school calculators didn't do that. They would just leave it like this, and you have to know like what order to put things in. And so that was like a day of lesson, like how do I put it in the calculator? And then they updated the operating system, and you're like, oh, that's beautiful. I just make it look like what's on my paper. From 1 to 2. Let's be careful with parentheses and making sure we square the right thing. Sine of x squared dx and the calculator can do all the work. Make sure you are in radians. That answer didn't look right to me. There we go. So my answer, my calculator integral answer is the 0.495. My answer to the problem is -5 minus that, -5.495. 3 decimal places, always when using the calculator. So, calculus to set the problem up. So this is one of those where if I just gave you a calculator before today, it wouldn't really help. But with a little bit of calculus and the calculator, you can get to the right answer. All right, flip it over. The graph of f prime, again, remember what you're looking at, the graph of f prime. And maybe we should be careful about where the axes are. It's kind of hard to tell. Consists of 2 line segments and a semicircle as shown on the right. Given that f of -2 equals 5, find f of 0. Well, I've got f prime and I want f. So if I know something about f prime and I want f, what should I do to f prime to get to f? Antiderivative. So let's antiderivative f prime. That will get us to f. Now, what x values should we use? For this one, what x values should we use? 0 and -2. So we want to know about 0, and they gave us something about -2. So let's use 0 and -2. Again, probably best to go from the smaller one to the bigger one. So from -2 to 0. So that ends up being f of 0 minus f of 2. All right, f of 0 is what we're looking for. F of 2, they told us. F of -2 is 5, so we can plug that in. What about this integral from -2 to 0 of f prime? How can I figure out what that is? What was the first thing we talked about that symbol means long ago? The area. Remember, it represents area from -2 to 0. So I go to my graph, and that means this area from -2 to 0. Let's see, that's just a triangle. 1/2 base times height. The area of that triangle is 4. I'm trying to write small to not get into the part B's work here. So f of 0 is, if I move the 5 over, is equal to 9. See if you can do B. See if you can do part B. Equals 13. Yes.
Would it be wrong if I did it like from 0 to 2? Because we already know.
No, that's a great question. You could do from 0 to 2 because you now know 0. Yeah. And these multi-part problems, you start getting lots of options for how you want to work it. Skip down to the very last one. Super quick on this one. It's a calculator problem because I'm not integrating that thing. A pizza with temperature 95 degrees is put into a 25 C room with T equals 0. the temperature is decreasing at a rate, and if you want to get rid of rate, rate is a derivative, so we want to integrate the rate to get to a temperature. If we integrate a rate, we get to a temperature. Estimate the pizza's temperature when T equals 5. Well, I know T equals 0, and I'm looking for T equals 5. So let's see, T5, T of 0. T of 5 is what I want. T of 0 is 95. Careful, the room is 25. And then this would be a calculator problem. Now, you will have to be careful with the decreasing thing because I think that's going to make this negative. And so it'll make sense because you know your pizza shouldn't be hotter 5 minutes later. It should be cooler. So be careful with the signs on some of these. All right, I gave you the homework. Try it. Answers are on the back. And answers are posted with work shown. So in Schoology, there's a little more work than just the answer. So give them a try, and we'll go over some of them tomorrow.